In this lesson, we will talk about errors and exceptions. Errors and exceptions are nightmare for the developers, and we will see how we can handle those. Firstly, let's see what is difference between an error and exception. Although in one way there is not much difference because both will cause the program to terminate. I have written a print statement without the parentheses and we know it is a wrong syntax, so it will generate a syntax error. What it means is that program never entered into the run mode. Let me add a few lines with correct syntax before this line. These 6 lines are correct, and then we have line number 7 with the syntax error. We see the error here, but note that we don't see the output of first 6 lines which are correct. It means our program never entered into the run mode. Now let's put the parentheses for this print statement, and I will remove the quotation marks this time. Now the syntax of this statement is correct, but there is a problem that Python will consider hello as some variable name and will search for that which is not in the program and will eventually generate an error. Let's see that. You see, we don't get the syntax error, we have a different error, and we also see this traceback which I will be discussing in a while. The program in this case entered into the run mode and could not execute the statement, and this error is known as exception. Let me uncomment the starting lines. See that we have output corresponding to first 6 lines of code and then an error on line number 7. This clearly shows that program entered into the run mode. These errors are also divided into runtime error and logical error, but both are exceptions and are different from the syntax error in a way that in case of syntax error, the code is not executed, while in case of exception, the code is executed and error is generated during the runtime. In both error and exception, the code is terminated and the program after that line is never executed. This prints the detail of the exception occurred, and this whole error information is because of the traceback module Python uses to print the useful information regarding the exception, which is helpful to identify the cause and resolve that. So that's about errors and exceptions. We can use the same term error for exception as well. Now as developer, we will try our best to remove all errors. If it is a syntax error, of course our program will not run and eventually we will remove that. But we are not sure about the other errors or the exceptions. Why? Because we may consider most of the possible scenarios for all possible exceptions, but still we can't guarantee that there won't be any exception. We design a software for the end user and he may not enter a valid input against some input entry, and that might cause some exception, and that will terminate the application, which is not a good experience for the end user who is the customer of our software. So we have the statement as try except, which we can use for this purpose, and it will not end the program in case of exception. Moreover, it is not just for the case that the end user is entering some invalid input, but for many other cases using the try except can be very time saving for us. So let's see how to work with try except. I'm copying a code. We have infinite while loop here, inside which we are taking 2 numbers from the user, and the task is to print the square root of the ratio of the 2 numbers. Then we are asking if user wants to rerun the code. If he selects not to re-execute, we are breaking the while loop. We are getting the square root of the ratio. Now this time if I will enter the second number as 0, we know division by 0 is not possible and it will generate an exception. See that our program has terminated with the exception message. The exception name is 0 division error and it is described as division by 0. Now I will enter one positive number and other negative number, and square root function of the math module generates exception for the negative input, and we get the exception. This time it is a different exception. The name of the exception is value error and description is math domain error. So there can be 2 issues with this program. One if second number is 0 and second when the ratio is negative. We can handle the 2 cases using the if statements. Hence we are first making sure the second number is not 0 and the ratio is not negative. And then we are applying the calculation. Now we will not have the error and the program termination. So the issue is resolved, but now we will see how we can handle this using the try except instead of the if statements. Here I am defining two variables and printing the ratio of the two. We know for these values there will not be any problem, but if b is 0, it will generate the 0 Boolean error. To handle that, instead of using the if statement, I will use the try, and I will write the statement inside the try block or try clause. What it means is the Python interpreter will try to run the block code, and if there is any error, it will not generate the error and terminate the program, and instead it will execute another block which is named as except, and it is a mandatory block with the try block. We cannot have a try block without the except block. Here I can print some appropriate message. So now if I run the code, Python interpreter tried to run the code given inside the try clause and there was no problem and we got the output. The except block is not executed in this case. Now if I make b equal to 0, now the interpreter will try to run the try clause, but we know there will be exception, but it will not generate the exception and will execute the except block. Let's see that. And here we can see the except block output. We call this as catching the exception, meaning that exception is not generated but caught by the except block. If we have anything after the try except block, that will eventually get executed. You can see the exception is caught by the except clause and then line number 8 is executed. So over here, instead of if else, we can use the try except. We will try to execute this statement. And then we will have the except block to catch any exception that might be 0 Boolean error or the value error or any other. Let's check this. Instead of 0 Boolean error, it displayed the message of the except clause. And now for the negative ratio, it will again execute the except block instead of value error exception. And if both numbers are valid, we are getting the square root of the ratio printed in the try block. At the moment, this except block will catch any exception that may occur in the try block, but we can be specific as well. I will explain that here. You should know that each exception that might occur has a specific name. For example, this 0 Boolean error is name of the exception, and then we have a brief description of the exception, which for this case is very obvious. If we try to apply the list class method append on the variable a, which is of int class, there must be some error. The name is attribute error, and then is the description that int class object has no attribute append. Likewise, if I have a dictionary, and if I try to access a dictionary item using the key which is not present inside the dictionary, there must be some exception. And the exception name is key error and description is just the name of the key. So let's see how we can use these names to be specific while catching the exception in the except clause. I have a try block printing the square root of ratio of a and b. I know there can be a 0 Boolean error, so I can have an except clause, and after the keyword except, I can specify the name of the exception. It means that it will catch just the 0 Boolean error exception and not any other. So I can have the appropriate message here. You can see it caught the exception correctly. But if we have other exception, for example the value error when the ratio is negative, it will not catch that and the program will generate the error. So we can have another except clause to catch the value error. Let's also print something after both except clauses. The ratio is negative and you can see the value error is caught by the respective except clause. And now try clause executed successfully. We are catching two exceptions here, and if there is any other, the program will generate error. For example, let's make the value of b a string, and this time there is different error since we cannot apply division between int and string. But we don't have any except block to catch that error. And you see we get this type error of unsupported operand type. We can have one more except clause to catch this error, but instead generally what we should do is that we create the except blocks for the specific exceptions that we want to catch, and then we can have a general except clause that will catch any other exception. I can display something like something wrong happened, and we get the message. The order of these except clauses is important. In case of some exception, Python will scan the except clauses in order. So if we have general exception clause at the top, then there is no use of specific except clauses beneath it, because all exceptions will caught by the general except clause. Anyways, you got the basic idea that we can have except clauses for specific exceptions and then a general except to catch any other exceptions that might occur. And program will never terminate because of the error inside the try block. We saw that errors were having some names and some descriptions. We can use those descriptions in the except clause as well. For that, we can write the keyword as followed by some identifier, for example v here. So in case of value error, the description of the exception will be in variable v, and we can use that inside the block. Let me make b as -2 so that the value error is generated. And here we see that after this message we have another message here, math domain error, which is basically the description of the error. Then we have the thanks message, which was outside all except clauses. For this general exception, if we want to access the description of the generated exception, we cannot specify the name for this, of course, as we have here for these. So we can have a general name exception for this, and then we can use as to get the description of the exception. I will make b a string to be caught by the last except clause. And you can see we have this message. And then is this message, which is the description of the exception. So we should have this thing here to catch the exception. I hope general idea should be clear by now. Remember that try except is not the replacement of if-else statement. For example, this if statement will remain here. Just the if statements which are used to check some condition which may lead to errors can be replaced with the try except. There are few more good reasons of using the try except instead of if statements. Let me first explain that, and then we will see that we can have the else clause with the try except, and we can also have a clause named as finally. We will see those shortly. I'm copying a piece of code. Here I have a list with 5 numbers having index 0 to 4, of course. Then I'm taking an index value from the user and I'm displaying the value inside the list at that index. We know if the index is out of the range, it generates error. So the first solution can be applying the condition first that entered index is within the legal range. I am not considering the negative indices. So if user enters a valid index, we will see the value at that index. And if the index is wrong index, we will see the other message. This approach can be termed as look before you leap. What it means is that we are applying the checks to make sure everything is fine before we run something. This approach is non-Pythonic approach. Pythonic is a term to indicate that approach is preferred by Python community for of course some good reasons. So it is not a Pythonic approach. On the other hand, I can use the try except approach. Try to run this. If it goes fine, that's perfect. But if there is any issue, then run the except clause. I think I misspelled beyond. Now we will get the corresponding block execution depending on the index value. This approach can be termed as it's easy to ask forgiveness than permission. It means that we are not taking any permission and trying to run this statement. If everything is good, we are good. And in case of any problem, we will catch that in the except block. This approach is Pythonic approach, meaning that it is suggested by the Python community. It is better than look before you leap approach. I will explain why it is better, but let's first see another example with these two approaches. In this example, I have a dictionary with the student information as his name, registration number and courses. Here I am just displaying the student information using a print statement, but first I am making sure that the keys I am getting from the dictionary actually exist inside the dictionary. Otherwise, there will be key error exception. This approach is look before you leap. Now let's see this Pythonic approach, which is it's better to ask forgiveness than permission. Here we are trying to print this information, and in case of key error, we are printing the message accordingly. If you remember, in case of key error, the error description is the name of the missing key. So we are using that as well in this message. In case we have all keys in the dictionary, we get the information displayed. Now if courses key is not there, it should generate the exception which will be caught by the except block. Now let's compare the two approaches and discuss that why try except approach is much better than the first one. Here we have to write a lengthy condition. Imagine if we have 10 or 20 keys to check, it will be even more lengthy. We don't have this case in the try except approach, no matter how many are the keys inside the dictionary. So with try except approach, we need lesser code. Second, even bigger advantage is that try except approach is efficient as compared to the if else approach. Because in if else approach, we are accessing the dictionary object 3 times to decide if we can run the print statement or not, even when everything is fine. On the other hand, in try except approach, if all keys are present inside the dictionary, we are straightaway printing the result. And you should understand that it is a very big advantage in terms of the efficiency of the code. Because in case of if statement, in every case we will be accessing the object 3 times, which will consume some time. And same goes for the previous list example. If the list index is within the legal range, there is nothing extra we need to do. The third advantage is better readability of the code. Some of you might disagree here, but I personally think that when we are using the try except block, it is very clear that what we want to execute and which error we want to catch. On the other hand, with if else condition, one will have to comprehend the condition to understand which error is being targeted to handle. So anyways, that was the try and except block, but there can be 2 more clauses associated with the try except. There can be else clause and there can be finally clause. Now let's see what these clauses do. The else block will get executed when there is no exception occurred in the try block. If there is some exception, the except block will get executed, and in that case else block will not get executed. This is a simple code to display the square root of x minus 10. For example, x is 2, and then we have the square root calculation in the try block so that if x is negative, it will be handled in the except block. Then is this else block, which will be executed when there is no exception occurred in the try block, meaning the square root of x is calculated. So here we can calculate that square root minus 10 and will print the result. When x is 2, this is the output, which is the square root of 2 minus 10. So else block is executed. And if x is negative, now we see the message of the except block, and the else block is not executed. You might be thinking that we can move the code of the else block inside the try clause and we will have the same result. Yes, but in this case there can be exception in any of the 3 lines, although we know that it will be on line number 6 and not on 7 and 8. But with the try block, we want to be specific that which code line we think can cause an exception. So for better readability, it is better just to keep the code which we want to handle inside the try block and do the other calculations in the else block. Then we have a finally block as well. I'm just printing a test string here. The finally block gets executed in both cases, that is if there is an exception in the try block or if there is not. For example, here x is negative and it will generate the exception which will be handled in the except block, and after that finally block will be executed. And if x is positive and no exception is generated in the try block, the else block will get executed, and after that finally will also get executed. You can see that from the output. Finally gets executed in both cases, whether there is exception or not. A very common question which arises is that why to have a finally block? Because if we remove that and bring the statement of the finally block here outside these try except clauses, now again this line number 13 will get executed in both cases, if there is exception or not. So then what is the use of the finally block? For that, see this example code. Here in the try block we are opening the text file. If file does not exist, there will be file not found exception, and that will be caught by the except block. Then is the else block where the file contents are read and processed. And in the finally block we are closing the file. Now why can't we just close the file outside the try except and the else clauses? There are 2 reasons for preferring the finally block. One is non-technical. We simply want to complete everything we want to do with the file in these clauses for better readability, and we'll start the further logic of the program after the finally block. Then there is one very important reason of using the finally block. Consider the same code without finally block, and file is being closed out of try except clauses. Now consider that file is opened in the try clause. It means the next clause is the else clause that will get executed. Now suppose that there is some exception inside the else block here. Of course the try block executed successfully because there was no error there, and then else block is to be executed. So there can be some exception inside the else block, and that is not being handled there. So the program will terminate there with an exception, and the file close statement will not get executed. You can well imagine that in such case, the file is opened but will not be closed because an exception occurred at some later stage. But if we have the finally block there, and now we have the same previous situation, the file is opened and the interpreter is inside the else clause, an exception occurs there, but now before the termination of the program, the interpreter will execute finally block and then will generate the exception to terminate the program. So we are 100% sure that finally block will get executed even if something wrong happens after the try block is successfully executed. So we put the important statement inside the finally block, like closing the file or database is really important, and we want to be 100% sure that those are closed no matter what happened. Then if we are using the try except clauses in user defined functions, the finally block can make a difference. Let me show that here. We have this list A. Let me put another number inside it, then a list B with 3 numbers. Then we are applying the function test on list B. Here is the function. What it does is that it will try to append the last element of the list B, which is the input argument, into the list A. If A is a list, which is for this case, it will get executed successfully. If A is not a list and is some other data type which does not support the append method, it will generate the exception, and that will be handled by the except block, where we are returning none. Then I have a finally block where I am just printing a string, and then we are appending 100 into the list B. So the goal of finally is that we want to append 100 into list B in any case, whether there is exception in try block or not. After calling the function, we are displaying the value of A and B. At this stage, A is a list, and hence there should not be any exception in the try block. We see finally printed means finally block was executed. The last element of B, which is 3, is appended into A, meaning try block is executed successfully. This is the value of B, which is because of this statement inside the finally block. Now if I make A as integer, it means that there will be an exception in the try block, and that will lead to execution of the except block. In except block we are returning none, and whenever a function executes return statement, it means that it will skip the remaining part of the function and will return to the point where it was called. But the power of the finally block is that interpreter will first see if there is finally block, and if it is there, interpreter will first execute the finally block and then will execute the return statement. Let's see that. You can see finally is printed means the finally block is executed. Value of A is 2 because the append method is not possible on integer. Except block has returned none, but finally was executed before the return, and you can see 100 is appended into the list B. Now if I don't have the finally block, and this statement of appending 100 into B is just outside the try except block, now in case of return none, this statement will not get executed. You can see 100 is not appended in the list B. I will make A a list and will place a breakpoint here. Let's press step into a couple of times. Now interpreter is in the try block, there won't be an exception, it will execute that and will look for the else block. It is not there, so it will look for the finally block. It will execute that and will return back to the main program. Now let's make A as integer. Now inside the try block there will be exception which will be caught by the except block. In except block there is return statement. We know that whenever there is a return statement, the interpreter returns back to the point where the function was called. But in this case there is the finally block. So instead of returning, the interpreter will move to the finally block, will execute the finally block, and then will jump to the return statement and will eventually return. So I hope it is clear why a finally block can be very important, and as I said earlier that we put the important things like closing the file or the database inside the finally clause, so that no matter what happens in the try except or the else clause, the finally block will get executed in any case. Also see that if we have some exception in the except block, it is deviant by 0 exception and will not be caught because it is not inside the try block but inside the except block. So there will be exception and termination of the program, but even in this case the finally block will be executed before generating the exception. So that's all from try, except, else and finally. In many cases we just use the try and the except clause, but you should know about the else and the finally clauses as well and use them as needed. There is one last thing I want to cover in this lesson. It is not about handling the exception, but it is about generating the exception, known as raising the exception. You will be wondering, why would someone generate an exception? Well, there is another programming paradigm known as object-oriented programming, where we create our own classes. Those classes are meant to be used by us, of course, but by other programmers as well. Meaning that we write the classes which other programmers might be using for their programs, and therefore certain cases we can raise the exception. The detail of course you will see when we will study about the object-oriented programming, but here I will just show how we can raise the exception. Suppose for quadratic equation solution I have three coefficients a, b and c. We know for quadratic equation we cannot have the value of coefficient a as 0. We can handle that using the try except, but I don't want to handle that, but I want to generate the exception if a is 0. For that we use the keyword raise followed by the name of the exception we want to generate. For example, value error. And in else we should do the calculations to find the equation roots. I will just put the pass statement. A is 0 and hence the exception is raised. If a is not 0, we see the thanks message of line number 7. We can also specify our customized message while raising the exception. We see the value error with our specified message. So that's all from this lesson. Thanks for watching.